Hey everybody, it's Peter from the Firebase team. When people ask me what's the best part of my job, I always tell them it's hearing from developers how they use Firebase to help them solve challenging problems and make the world a better place step by step. So I'm really excited that I recently had the chance to sit down with a couple of developers from the Firebase community and chat with them about how they use Firebase and how it helps them tackle challenging issues. In this episode of Firebase Stories, you'll hear from electric ride-sharing app MOIA how they use Crashlytics and Remote Config to optimize their apps. I also had the chance to meet with FAVES, an app that makes the buying process for fashion retailers more manageable using the Realtime Database, Cloud Functions, and the Cloud Vision API. So, grab a snack, kick back, and enjoy. Today, I'm here with Matthias from the MOIA team. Hey Matthias, how are you?
Hi there, I'm fine. Thanks for welcoming me.
As far as I know, MOIA is a ride-hailing app, but with a twist. Can you explain what that is?
Yeah, exactly. We call ourselves more ride pooling. So we really focus on pooling people together who want to go into a similar direction in the city. And with that, ideally have a good impact on the urban life nowadays.
I can see that you've got two application windows open. So maybe instead of just talking about the application, how about we dive into how it actually works? Can you demonstrate that to us?
Yes, let's do that. On the right-hand side here, we see basically the application which the driver sees in front of our vehicles, which provides the navigation. And on the left-hand side, I'm now going to start our passenger application, which our customers use to book a MOIA trip. So here it now located me to my current location, of course, but let's say we want to start somewhere around here in Hamburg. I know the vehicle is around there roughly. And now let's request a trip. And of course, we also need to choose a destination where we want to go to. Let's say, here to the inner city. Then we could choose like how many people want to ride with a MOIA, do we need a child seat, and so on. And get some offers. Here we now see several offers, which our fleet should be possible to provide. And we also have some express option here, which basically limits the time frame into which other customers can get booked in. Also some dynamic pricing in place there. But let's try just to book something simple. And now the backend went basically over our fleet state and it directly assigned our vehicle here.
Okay, so now the vehicle will go to pick up the pretend customer.
Exactly. Now here on the right-hand side, we just have this for debugging reasons where you can basically simulate the driving according to the route we have. And with that, we should also be able to see the vehicle moving here.
All right, so the car arrives and then you bought the car, I guess?
Exactly. Now the driver would be welcoming me at the door. I would get in, take a seat and put the seatbelt on. And then the driver would tell the system that I bought it. And now we see that the driver application got a new route towards the destination, which I, as a customer, picked. And let's start driving there as well.
What happens if there are other passengers on the same vehicle? So let's assume someone else is on the vehicle and they have a stop that is in between where you entered the car and your final destination.
Yeah, then another trip would appear here for the driver to take note on. And the route would directly also switch to that pickup destination of the other customer.
So maybe while it's still driving there, we can talk a little bit about how the application is built.
Yeah, in the end, we have the customer application for both iOS and Android, of course. The driver application, which you see here on the right side, is just existing on Android because we control the hardware there. And we also have a third application, which we use internally for our operations and shift handling of the drivers and so on. That is actually fully written in Flutter. So we also provide it for Android and iOS. In all our applications, we use Crashlytics a lot to monitor basically the stability of them. But we also use a lot remote config to roll out features in staged rollout phases, or also like to test features for maybe some small amounts of vehicles first and collect feedback from the drivers, or also see how customers are using these features in the customer application and learn from them and improve them.
So how about we look into remote config and how you use that?
Here we have remote config from our passenger application. And as you can see, we have quite some remote configuration values here. So we group them a bit fitting to our different feature teams or to the respective feature groups. And yeah, we have quite some there. Also setting different values for different build types. For example, for production, for integration, or debug build type, and so on, both for Android and iOS. Basically, every new feature we build behind a feature flag, and then it ships early on, even in the app already. But just when we know it's finished, we enable it for the first few users, maybe, or do an A/B test, alternating it to a different variation of the same feature with a different layout.
I'm guessing that with so many features that you have, and with an application that is being used by many users in the real world, and actual trips, depending on that, you want to make sure that everything that you develop is actually well tested. So how do you do that? Do you have a lot of integration tests and unit tests to make sure the application is always in a good state before you roll stuff out?
Yes, exactly. We unit test all our logic, basically from the data layer all the way to the view model as much as possible. But also we do integration and UI tests and run them in the cloud, then on Firebase Test Lab. And here we, for example, can see a test lab of our passenger application as well, and some test runs for it. I, for example, also would have a small pull request here, which already did run some tests. And here we, for example, can also see that we integrate these from Firebase to our GitHub pull request directly, and can see the state of these.
I'm guessing that with so many features that you have, and with an application that is being used by many users in the real world, and actual trips, depending on that, you want to make sure that everything that you develop is actually well tested. So how do you do that? Do you have a lot of integration tests and unit tests to make sure the application is always in a good state before you roll stuff out?
We can maybe take a look at one of the test runs here. And there we should be able to find some videos, as well as maybe see that it takes lots of screenshots from the test run. Here is the video. Yeah, we could go through that now, but usually the tests run so fast that you can't really spot that when you don't know the direct time. But what is more interesting is that it takes lots of screenshots from the different UI states. And with this, you can really dig deep into your test runs and see what what maybe didn't work out that nice, and with that more easily fix it.
Thanks for taking us behind the scenes and showing how the MOIA application works, what it means, how it looks like for users, and also from the driver's seat, and giving us the opportunity to see how we use Firebase to make operating this system and developing for it a lot easier. Yeah, thanks for being on the show, Matthias, and hope to see you soon. Hey Mark, so today we want to talk about the FAVES app, and maybe to get us started, can you introduce yourself and what the app does a little bit?
Sure. Well, I'm the CTO here at FAVES, and the FAVES app is an app that we developed for fashion and home decor retailers to help them with purchase planning and order management. And we made it because these particular kinds of retailers face some very specific challenges in how they do their wholesale buying. They're often purchasing products 3 to 9 months in advance of when they will be delivered. And they're basing these decisions typically on pre-production samples rather than finished goods. And so they need to take pictures to remember what they saw and to make sure that what gets delivered is actually what they bought. And it's very difficult to avoid, or they need to avoid overbuying, for example, because over this long period of time, it's easy to forget what you've purchased already or to forget things. So that's why we made it. And I thought, if you don't mind, maybe a better way to explain it is just to show it. So we have our CEO, Ula, is in Dallas, Texas right now at one of America's largest fashion trade shows. And she'd be happy to give us a quick demo of the app.
Dallas Market is one of the many apparel trade shows that are going on here in the US. And this one here is humongous. It's 15 floors, and it's 5 million square feet of vendor space. And during these 4 days, during the apparel trade show, there are approximately 15,000 attendees. So I'm going to go ahead now and go in and visit actually one of the booths and show you how the FAVES app works. So what we're going to do in here, we're actually going to go ahead and take a picture of the product first, just like a boutique or a buyer will do. So we're taking a picture. Next up, we're going to tap the scan icon, and then we're going to scan the text. We're going to take a picture, and it's going to read that text in. So we see we got the style number, the color, the price, and also the delivery information. So I'm going to just go ahead and press save. And you can see it got in. I'm going to tap done. And that's it. That's how we actually use the FAVES app at Market.
Wow, that was amazing. So how does that happen? I mean, how do you get the information from the phone up into the cloud? How do you get the information from the tag into the database? Can you walk me through that?
Absolutely. Right. So what happens is as soon as the app takes that tag photo, it gets pushed up to Firebase storage. And that file write into a storage bucket triggers a cloud function. And that cloud function, in this case, is our OCR, or our tag recognition function. And we can see that here. I'm looking at a database node where the results of the tag recognition appear. So after the tag recognition process runs, it writes results to a database node. And the app, meanwhile, has an observer on that node. So it's immediately notified when there's a write to that database node, and it's recognizing this particular ID because that's the ID of the photo that it dropped in the storage bucket. So then it looks at these results and displays them for the user, and then the user has the opportunity to accept or reject them. And I could show you that momentarily, our analytics on that. But yeah, so once those results, if they are accepted, then they get pushed into the product record proper. And that's at a different database node which we see here. And so I can show you, for example, this is the product. And you can see like we have this scanned text here, and that's here in the note field. We have a delivery date in Unix format, and that's showing up here. If there were multiple months, there would be an end date as well. And here, for example, is the price record. And I can demonstrate for you what happens if we make a change. So if the user says, oh, I only want 5 of these, and hits save, if you watch the database, you see that gets updated immediately. And in fact, we also have the modification user and date, so there's some tracking there as well. It's super useful. One of the things I love about Firebase is this JSON structure and the ability to go into the console and very easily edit things. We don't edit products typically, but sometimes there's something like a user made some kind of mistake or whatever. I can go in and actually fix it. But also just for observation and analytics and database backups and so forth, it just makes things so much easier.
In terms of the barcode recognition, so it looks like the barcode that we can see in the screenshot, that doesn't look like a regular barcode like you would have on a can of milk, for example. So
right.
I assume those barcodes are very specific and special, and that there might be a lot of different ones. So how does that work? Do you actually read the barcode, or do you read the information that's on the tag?
Well, yeah. So the thing is that at these wholesale markets, the products on display are samples of pre-production. So they do not have UPC, standard retail barcodes on them. If they have a barcode at all, it's typically referring to some internal inventory number or something for that vendor. And so, and we don't have access to that data. So the barcode is really useless for us. So that's why we developed our scanner to actually read the text on the tag and make a best guess at interpreting that information. So we literally perform OCR on it using Google Cloud Vision, and then from that we structurize the data, and through our own algorithms, basically do our best guess at figuring out what information is on that tag. And when we do that, as I showed you earlier, we get the tag recognition results here. This information, together with the analytics that we capture for the user, will help us to, in the future, to be able to train our machine learning model using actual user-validated training data.
Yeah. That makes sense. So I guess using a full-on cloud vision model probably was something that would have taken a lot more data and time. So you decided, let's build something that works right now, build a solution that operates on the data that we have at hand while retaining the data so that we can use that in the future. That makes a lot of sense to me. So can you show us the cloud function that does that?
Sure, let me call that up here. So a great thing about cloud functions is that you can write them in either JavaScript or Python. This one is written in Python. And when you're writing cloud functions, probably the first thing you need to know is that there are various ways you can trigger them. For example, there's database activity, such as when a node is created, updated, or deleted. There are HTTP requests, which is where your app or some external caller calls a Firebase endpoint over HTTP. And then there's storage bucket activity, such as when files are created or deleted. This particular function uses a storage bucket trigger. So let me show you how that works. So if we go here to main, this is the entry point of our cloud function. And when your function is invoked, Firebase passes 2 parameters named data and context. The context parameter provides metadata about the trigger event itself. In this case, storage object finalize, which means that a file was created or rewritten. The data parameter is a dictionary that provides details about the event. And the main thing we're interested in here is the name. So here you can see that the name consists of two parts. The first part is the ID or the account ID of the user who took the tag photo. And then this is the file name that was created. So with that, we split that name into the file name and account ID components, and then we call the doOCR function to do the work of extracting the text and bounding boxes from the image. So let's have a look at that. So here's where we call Google Cloud Vision, and specifically we call the text detection function. When Cloud Vision performs OCR, it finds all the text-like objects in the image, and it returns the coordinates as bounding boxes for each individual character, as well as for groups of characters like words and paragraphs. So let me show you that. Here we have an example response from Cloud Vision. And if we scroll down a bit to the text annotation part, you can see that it's organized into pages. And within pages, you have blocks. And within these, you have things like paragraphs and words. And if we scroll down far enough, let's just randomly pick a spot here, you'll find letters, or in this case, a number 2. Here's a number 0, 5. I guess we hit some numbers. But anyway, each individual character that was found, we will have a specific bounding box for that. So because of this, this text response can get quite large. In fact, this particular one is over 5,000 lines. The other thing that can happen is that it doesn't happen often, but sometimes users will take a photo that doesn't have any text on it that Google can find. And so the first thing that we do is we look in this field, which contains all of the text that Cloud Vision found within the image. And if there's nothing here, then there's no need to continue on to the next phase. So let's go back to our cloud function. And so assuming that we got some text back from the doOCR function, then the next step is to call this function to extract just the relevant elements from the Cloud Vision response. Because as you saw, it's quite large response, and we're not interested in the individual letters. We're only looking for word groups. So that's what this function does, is it just returns the text we're interested in and the bounding boxes. And then with that, we can call this function. Given that a label can be scanned in any orientation, we need to do some fancy math in order to figure out which words actually belong together on the same line and in the proper order. And that's the purpose of this function. And so then with that structured text, we can then actually do the hard work of extracting the relevant information, such as price, colors, delivery dates, style names, style numbers, etc. This is our secret sauce, and we're constantly improving this function. Finally, we can save the results to the Realtime Database, as I showed you earlier. And when we do so, this write to the database will trigger the observer that's waiting in the FAVES app to display the results to the end user. And then they can choose whether to accept those results or which parts of the results they want to accept.
Well, thanks, Mark. That was amazing. I really liked, the utility of the application, and it was amazing to see how you use all the Firebase products to make that happen. And it looks like this application might be really useful for me if I wanted to start a boutique of my own and maybe upgrade my closet, right?
Well, absolutely. And if you do that, let me know. I'll give you a personal introduction.
All right, deal. It's so great to see how developers like you use Firebase to build great apps and make the world a better place. If you'd like to learn more about MOIA and FAVES, check out the Firebase Stories site. We also want to hear your stories. So if you're using Firebase to build an amazing app, let us know. Send a tweet using the Firebase Stories hashtag, and we might feature you on one of our social channels. Thanks for watching, and I will see you soon when we next talk about Firebase stories.